December 1979, Palo Alto, California. Inside a windowless demonstration room at a research lab most of the country had never heard of, a 24-year-old college dropout is packing back and forth, unable to sit still. He isn't an executive. He isn't even supposed to be running this meeting. But partway through a routine technical presentation, he suddenly cuts the room off mid-sentence. Stop, stop, stop this discussion. We need to tell them about the Lisa. A few minutes later, watching a live demonstration on a machine unlike anything on the commercial market, he can barely contain himself. He turns to the scientists in the room, almost shouting, "What is going on here? You're sitting on a gold mine. Why aren't you doing something with this? You could change the world." The young man was Steve Jobs. The machine he was looking at was the Xerox Alto. And the technology in front of him, a mouse, overlapping windows, icons you could drag across a screen, a document that looked on screen exactly the way it would look printed on paper, would go on to define the entire visual language of personal computing for the next 50 years. Every phone you've ever unlocked, every laptop you've ever opened, every icon you've ever dragged into a trash can descends in a direct, traceable line from what Jobs saw in that room. Here's the part that makes this story almost impossible to believe. None of it was built by Apple. All of it, the mouse, the graphical interface, the windows, the icons, even the office network connecting it all together, had already existed, fully working, inside Xerox's own research labs for 6 years before Jobs ever walked through the door. Xerox built the future of computing first. And then, through a combination of corporate blindness, internal politics, and a stunning failure of imagination, handed it to somebody else almost by accident. This is the story of how the company that invented the personal computer, as we know it today, ended up watching someone else take credit for the revolution and get almost none of the reward. To understand how something this consequential could slip through a company's fingers, you have to go back 9 years earlier, to a moment when Xerox had more money than almost any company on Earth, and no idea, yet, what it was about to build with it. By 1970, Xerox was one of the most profitable companies in America, built almost entirely on a single product line, the photocopier. The company's core machines threw off so much cash that Xerox's leadership faced an unusual problem: what to do with money the copier business alone couldn't reinvest fast enough. Their answer was to build a research laboratory unlike anything else in corporate America. The Palo Alto Research Center, PARC, founded in 1970, 3,000 miles from Xerox's actual headquarters on the East Coast. That distance wasn't an accident, and it wasn't just geography. Xerox deliberately placed its most ambitious research arm near Stanford, in the same Northern California ecosystem that was already producing the engineers and ideas coming out of the era's government-funded computing research. The man Xerox recruited to help build PARC's computing group, Bob Taylor, had previously run the ARPA office that funded the very research culture that gave rise to time-sharing computers, early networking, and interactive graphics. Taylor pulled together a team of researchers who had, in many cases, already been dreaming about the future of computing for years, and gave them something almost no research group before or since has ever been handed: real money, real freedom, and remarkably little day-to-day oversight from the executives 3,000 miles away who were, at that exact moment, busy protecting a copier monopoly. The culture Taylor built inside PARC's computer science lab was unlike anything in corporate research at the time. There were no rigid hierarchies dictating who could work on what. Researchers argued as equals in open common rooms, wandered freely between each other's projects, and were judged less on delivering a quarterly product than on doing work their peers would respect. It was closer to a university department than a corporate division, which was exactly the point. Xerox's leadership, whatever else it misjudged about the value of what PARC would eventually build, had gotten one thing profoundly right at the very start. Brilliant, ambitious researchers do their best work when nobody is standing over their shoulder asking when the product ships. That same freedom, ironically, would later become part of the very problem that kept PARC's inventions from ever reaching the outside world in Xerox's own hands. Among the researchers Taylor's group would come to include was a computer scientist named Alan Kay, whose vision for computing was strikingly different from almost everyone else working in the field at the time. In an era when a computer meant a room-sized machine that dozens of people shared through terminals, Kay imagined something he called the Dynabook, a personal notebook-sized computer, simple enough for a child to use, that would function less like an industrial tool and more like an active medium for thought, creativity, and play. It was a radical, almost fantastical idea in 1970. Nobody built anything resembling it for a general consumer market for another decade. But that vision, a computer built for a single ordinary person, not a corporation's data processing department, became the philosophical seed for everything PARC would go on to build. What happened next, inside PARC's computer science lab, was one of the most concentrated bursts of foundational invention in the history of technology. A small team led technically by an engineer named Charles "Chuck" Thacker, working alongside Butler Lampson and others, set out to build a working machine that could embody Kay's vision, not a paper concept, but an actual computer sitting on someone's desk. By March 1973, that machine was operational. They called it the Alto. What made the Alto extraordinary wasn't any single feature. It was how many pieces of the future it managed to assemble in one place, years or decades before any of them became standard anywhere else. It had a bitmap display, meaning every pixel on the screen could be individually controlled, allowing real graphics and real typography instead of blocky text characters. It had a mouse, a pointing device based on earlier research by Douglas Engelbart, refined into something a normal person could actually use to click and drag. It had overlapping windows and on-screen menus, letting a user work on multiple documents at once instead of one rigid full-screen task at a time. It had Ethernet, a local networking standard developed at PARC by Bob Metcalf and David Boggs in that same period, letting Alto machines share files, mail, and printers with each other years before anyone outside a research lab had ever sent an email. And it had Bravo, widely regarded as the first WYSIWYG, what you see is what you get, text editor, where the words on your screen actually matched what would come out of a printer, instead of forcing users to imagine formatting through lines of invisible code. Put together, the Alto wasn't just an impressive research prototype. It was, conceptually, the first personal computer system in a form we would still recognize today, a machine built around the idea that ordinary people, not just trained specialists, should be able to sit down and use it. Lead engineer Chuck Thacker later noted that the first Alto had cost Xerox around $12,000 to build. If Xerox had ever sold it as a genuine commercial product, the price tag would likely have landed somewhere around $40,000, an astronomical sum for what was, in essence, a machine 10 years ahead of anything the mass market was ready to buy, or that Xerox was ready to sell. Walk through PARC's halls in the mid-1970s, and you would have seen something almost nobody else on Earth could show you. Researchers sending each other electronic mail between offices years before that word meant anything to the public. Documents being edited on screen with the same fonts, spacing, and page breaks that would come out of the printer down the hall. A shared network letting one laser printer serve an entire floor of Alto machines, instead of every desk needing its own dedicated hardware. None of this was demonstrated as a novelty. Inside PARC, by the mid-1970s, it was simply how people did their jobs every day, which is exactly what made it so easy for the outside world, and even Xerox's own leadership, to underestimate just how far ahead of everyone else this small research group actually was. Roughly 2,000 Alto machines were eventually built, almost all of them staying inside Xerox itself or going to a handful of research partners and institutions. The machine was never manufactured or sold as a mass-market product at all. And crucially, the Alto wasn't the only piece of the future quietly taking shape inside PARC's walls during this same period. Another invention, born out of very similar internal friction, would end up telling us almost everything about why Xerox handled the Alto the way it did. Around the same time, the Alto team was building its machine. An optical engineer at PARC named Gary Starkweather was working on an idea of his own, using a laser to print an image directly onto a photocopier drum, pixel by pixel, turning a copier into something that could reproduce anything a computer could generate on screen, not just whatever paper document you fed into it. It sounds, in hindsight, like an obvious extension of Xerox's core business. At the time, it was almost the opposite. Starkweather's own division, the engineers and managers responsible for Xerox's existing copier product lines, actively opposed the idea. A laser printer, in their eyes, wasn't an opportunity. It was a threat to the copier business that funded the entire company. According to accounts of the period, the resistance was serious enough that Starkweather was told, in essence, to drop the project, and he came close to being pushed out of the company entirely for refusing to let it go. It took the intervention of PARC's own leadership, researchers and managers who saw the value the copier division couldn't or wouldn't, to protect Starkweather's work and give it a home inside the research lab rather than letting internal politics kill it outright. This time the story had a different ending. The laser printer, unlike the Alto, eventually made it out of PARC and into the real world as an actual Xerox product line, and it went on to become one of the most profitable technologies the company ever built, generating enormous revenue for decades. It's worth sitting with that contrast for a moment, because it tells you something important. Xerox wasn't incapable of recognizing and commercializing what PARC invented. It had done exactly that successfully with the laser printer, which makes what happened with the Alto not a story about a company that couldn't see value in new ideas at all, but a story about one specific, enormously consequential blind spot in one specific part of the business at one specific moment in time. What separated the two outcomes wasn't the quality of the invention. By most measures, the graphical personal computer was the more important of the two ideas, the one that would go on to reshape how thoroughly ordinary people related to computers at all. What separated them was who inside Xerox actually understood what they were looking at, and how directly that understanding connected to a business the company already knew how to run. The laser printer threatened one division, and once protected by PARC's own leadership, slotted naturally into a sales and manufacturing machine Xerox had spent decades perfecting. Printers and copiers, sold to offices, serviced by the same technicians, billed through the same channels. The Alto threatened nothing in particular, which in a strange way made it easier to ignore. There was no obvious business unit whose survival depended on someone at headquarters paying close attention to it. Xerox's corporate leadership sat on the East Coast, first in Rochester, New York, later in Stamford, Connecticut, men whose careers had been built on selling copiers to large corporations, not on understanding graphical interfaces, networked personal computers, or the kind of speculative research culture PARC had been built to house. PARC's researchers gave demonstrations. They wrote reports. Xerox executives were shown, repeatedly, over the course of years, a working machine that let a person edit documents visually, send messages instantly to a colleague across the building, and print exactly what appeared on their screen. And largely, none of it translated into urgency at the top of the company. Part of the problem was structural. PARC had been deliberately built far away from headquarters, insulated from day-to-day corporate pressure, specifically so its researchers could think freely. But that same insulation meant the people making Xerox's big strategic bets simply weren't in the room often enough to feel the full weight of what was being built. Part of it was cultural. A company whose entire identity and revenue engine ran on copiers sold to large enterprise customers didn't have an obvious internal instinct for what a machine built for a single ordinary person, sitting on their own desk, at their own home, might eventually be worth. And part of it, later observers would argue, was a simple failure of imagination, the inability of a company at the absolute peak of one business to seriously imagine that its future might not look anything like its past. Whatever the exact mixture of causes, the result was the same. For the entire second half of the 1970s, Xerox had, sitting inside its own research lab, arguably the single most important computing prototype ever built. and no serious company-wide plan to turn it into a product ordinary people could buy. By 1979, Apple Computer was a small, fast-growing startup, not yet publicly traded, and hungry for capital to fund its next stage of growth. Xerox's venture capital arm saw an opportunity and invested $1 million for 100,000 shares of pre-IPO Apple stock. Attached to that investment, according to multiple accounts from people involved, was an informal, almost unspoken understanding. In exchange for the money, Apple's engineers would get a look inside PARC. There were actually 2 separate visits by groups from Apple to PARC that year. Steve Jobs attended the second one, arriving with a small team that included programmer Bill Atkinson and Jeff Raskin, the Apple engineer who had originally pushed to arrange the visits in the first place, reportedly hoping that seeing serious outside interest in PARC's work would help him convince Jobs to take the ideas behind Apple's own in-progress Macintosh project more seriously. Jobs, it turned out, had his own reasons for wanting in the door. Inside PARC, a researcher named Adele Goldberg, who had helped build the Smalltalk programming environment running on the Alto, initially refused to give Jobs and his team a demonstration at all. She suspected, correctly as it turned out, that showing Apple the full capability of what PARC had built would mean handing a competitor the company's most valuable unreleased ideas on a plate. She argued against it for hours. Her Xerox superiors overruled her anyway and told her, in effect, that if the demonstration was going to happen, it would happen on their orders, not hers, a decision she would later describe, without much subtlety, as giving away the kitchen sink. What happened next has become one of the most retold moments in the history of Silicon Valley, occasionally exaggerated into a kind of theft narrative that people who were actually in the room have since pushed back on. Jobs wasn't secretly stealing anything. Xerox had, quite deliberately, opened the door and walked him through it. But what the eyewitness accounts agree on is the sheer intensity of his reaction. Watching a live Smalltalk demonstration led by PARC scientist Larry Tesler, with Apple's Bill Atkinson standing so close behind him that Tesla could feel his breath on the back of his neck, Jobs paced the room, interrupted his own team's questions, and repeatedly pressed PARC's researchers on why none of what he was looking at had ever reached the outside world. He would later put it more simply. It was obvious to him, in that moment, that all computers would eventually work this way. The scientists in the room that day remembered it less as a calm handoff of ideas and more as a kind of controlled chaos. Jobs didn't sit quietly taking notes. He interrupted, redirected, demanded specific demonstrations, and openly marveled, out loud, at technology the PARC researchers had spent years treating as simply part of their everyday working environment. For people who had built and used this technology for so long that its novelty had worn off entirely, watching someone react to it with that kind of raw astonishment was its own kind of revelation. A reminder, delivered by an outsider, of just how far ahead of the rest of the world their unglamorous daily tools actually were. On paper, the financial side of the story actually worked out for Xerox, at least at first. Apple went public a little over a year later, in December 1980, at $22 a share, closing its first day of trading at $29. Xerox's 100,000-share stake, purchased for $1 million, was suddenly worth several times that on paper. Judged purely as a venture investment, Xerox's $1 million had been a genuinely good bet. But a good stock return was never really the prize here, and everyone involved understood that even at the time. What Jobs took out of PARC wasn't a technology license or a set of blueprints. It was a conviction and a direction. Apple folded what its team had seen into the Lisa, the company's first attempt at a graphical, mouse-driven computer, and then, when the Lisa proved too expensive for most buyers, into a far more affordable follow-up. The Macintosh, launched in January 1984, the first mass-produced computer built around a graphical interface, a mouse, and a screen designed to feel approachable to someone who had never used a computer in their life. Xerox, meanwhile, finally attempted to bring its own invention to market 2 years earlier, in 1981, with a machine called the Xerox Star. It had the windows, the icons, the mouse, the networking, everything PARC had spent most of a decade building. It also carried a price tag of roughly $16,000 per unit, sold primarily through Xerox's existing enterprise sales channels built for moving copiers into corporate mailrooms, not personal computers into homes or small offices. The Star was, by nearly every account, a commercial failure. The very company that had invented the graphical personal computer couldn't figure out how to sell one to an ordinary customer, at a price an ordinary customer could pay, through a sales organization built for an entirely different kind of product. It's tempting to tell this story as a simple morality tale, a slow, sleepy corporate giant that couldn't see what was right in front of it, versus a hungry young startup that could. The truth sitting underneath it is a little more uncomfortable than that, and a little more useful too. Xerox didn't fail to invent the future. It succeeded at that more completely and more early than almost any company before or since. Nearly every visual idea that defines how we use computers and phones today, the mouse, the desktop metaphor, overlapping windows, clickable icons, WYSIWYG editing, even the basic idea of a computer network connecting ordinary desks to a shared printer and shared mail, existed, fully working, inside PARC by the mid-1970s. What Xerox failed at was something different, and, in its own way, harder, recognizing that a genuinely new kind of product sometimes has no natural home inside the structure of the company that invented it. The laser printer succeeded because it could be sold, however uncomfortably at first, through the same basic channels Xerox already understood. As an accessory to the copier and office equipment business, the company already knew how to run. The personal computer had no such home. It demanded an entirely different kind of company, one built around individual consumers instead of corporate procurement departments, one willing to sell a machine at a loss to build a market instead of protecting the profit margins of an existing one led by people close enough to the research to feel its urgency instead of receiving it as a quarterly report from 3,000 miles away. Apple, as it happened, was exactly that kind of company at exactly that moment, which is really the sharper, less comfortable version of this story. It isn't that Xerox failed to see the future. It's that Xerox built the future, correctly identified almost everything important about it years ahead of anyone else, and then discovered that inventing something and being the right company to bring it into the world are not always the same skill, and not always housed inside the same set of executives, incentives, and sales channels. Every time you drag a file into a folder, every time you click an icon instead of typing a command, every time you look at more than one window open on a screen at once, you are looking at a piece of Alan Kay's Dynabook Vision and Chuck Thacker's 1973 machine, filtered through 50 years of refinement, running on hardware unimaginably smaller and faster than anything PARC's engineers had access to, but built on the same basic ideas they worked out first. The mouse in front of you, wireless or not, still traces its lineage through that same lab. The very metaphor of a computer desktop, with its folders and its trash can, is a direct descendant of Choice's PARC researchers made about how to make an intimidating machine feel familiar to an ordinary person sitting down in front of it for the first time. Xerox, for its part, never became the personal computer company its own researchers had effectively already built inside its walls. It remained, for the rest of the 20th century, largely a company that made copiers and printers, a very good one, profitable for decades, built in no small part on PARC's other great invention, the laser printer, and on the patents and expertise that came out of the very same lab that gave the world the graphical interface. It simply never found a way to be both companies at once. Years later, Xerox would even try, unsuccessfully, to reclaim some piece of what it had lost through the courts, filing a lawsuit against Apple in 1989, alleging that Apple's graphical interface infringed on Xerox's own copyrights. The case went nowhere. A judge ruled that Xerox had waited too long to bring the claim, and the ideas that had walked out of PARC a decade earlier stayed exactly where they had landed. By then, the shape of the industry had already been set for years. Microsoft, watching Apple's success with the Macintosh, built its own graphical operating system, Windows, prompting a separate, equally famous legal battle between Apple and Microsoft over how much of the graphical desktop metaphor any one company could actually claim to own. Both fights, in their own way, were arguments over the inheritance of a single afternoon in a PARC demonstration room, an inheritance that, by the time the lawyers got involved, Xerox itself had already let slip entirely out of its hands. And so the machine a 24-year-old walked out of PARC having seen for a single afternoon in December 1979 became, within 5 years, the shape of computing for the rest of the century, built by somebody else, sold by somebody else, and remembered by history as somebody else's invention, even though every essential piece of it had already been sitting on a desk in Palo Alto, working, years before Steve Jobs ever knew it existed.